to be good ambassadors when we are exploring other planets, other moons. So it's the right thing to do.
How does it feel? It feels great. Hi, my name is Heather Bottom, and I'm helping prepare the spacecraft that will fly our next Mars rover to the Martian surface. So here we have the rover test facility for the Mars 2020 project. So the goal of Mars 2020 is to collect samples of the surface of Mars and perform lots of other exciting experiments. There's 7 different instruments on the rover. Some of the work that's being done here right now is integrating the arm and the mast. My role is mostly on the systems engineering of the launch and cruise phases of the mission. It's essentially getting it to Mars. As a systems engineer, you kind of have to put those different pieces together and make sure that those pieces all are going to work. You get to kind of see the bigger picture. Before the rover actually flies, you have to make sure that everything works properly with the flight software and the hardware. So I have a really unique story. I actually ended up becoming a professional dancer in New York, and I really lived that out to its fullest and wear all the makeup and rhinestones and things. But for some reason, I always knew I was going to come back to this kind of curiosity that I've always had with space. There's some of that creativity here too. Sometimes I feel like we're kind of like the stagehands in this big production for the rover. It's bringing together a bunch of people, it's making sure that the hardware works, and it's kind of similar to a performance where, on launch day, it'll be the opening night, which is what we're all here for.
How often do you get to say you work next to a robotic system that's going to Mars, right? There's not many places in the world that you can do this. My name is Eric Aguilar, and I'm working on a robotic system that will be collecting Martian rock samples so they can be studied on Earth. This is our hexapod test bed. It's basically a rover body that allows us to attach, the robotic arm, the adaptive caching assembly, the drill. So that's where a lot of the testing happens behind me. The sample caching system will use a robotic arm and drill to actually take samples out of the ground. And we're looking for evidence of life that may have existed on Mars. The smaller arm that lives inside the belly of the rover and is used to actually process the tubes as they come back with a sample inside. We'll measure it, take some pictures of it, and get it sealed and stored for a future mission to pick them up. You see the robotic arm stretched out, and we have a bunch of engineers and technicians working on installing a model of our drill. Working in aerospace, that was always a passion of mine. What really draws me towards it is the engineering of it. Always working on something new and something that's never been done before. Finding those problems, getting them fixed is really something that I enjoy. In 20 years, the children will be reading this in their science book, and I kind of cherish that.
I'm actually putting something together that's flying to Mars. My name is Michelle Tommy Colizzi, and I'm helping to protect the next Mars rover. The main objective of this rover is to cache samples. They're drilling core samples, and then they will drop them in specific locations on the surface of Mars in preparation for a sample return mission. So what we can see over here is the stacked spacecraft. My role on Mars 2020 is Assembly, Test, and Launch Operations, which is ATLO, where all of the delivered components of hardware come together and make the spacecraft. In the southwest corner over here, we have our Flight Mars 2020 rover, and we have the entire mobility team installing the rocker bogie mobility system. We try to test all of our hardware to the environments that we would see for launch of the vehicle, for cruise, the journey from Earth to Mars, for the entry into the Mars atmosphere, for landing, as well as the surface of Mars. Every once in a while we come up and take a quick look. With all the craziness, you kind of lose sight of it a little bit. Over the years, it becomes like your non-living child. So you really want to see it do well and perform the best that it can. It reminds you that, hey, everything that you're touching and all this hard work that you're putting in the long hours, if it was easy, everyone would be doing it. We're sending hardware that we built on Earth to another planet to go and do science.
The Cold Atom Laboratory is in many ways the coolest thing and the coldest thing we've ever done on the International Space Station. It is allowing us to investigate cold quantum gases and make breakthroughs in areas of physics that up until now have been unavailable to us.
NASA built the International Space Station to do the kind of research that we're doing in the Cold Atom Lab. This is the first time we're able to study this fifth state of matter in space.
Bose-Einstein condensation is an amazing feat of engineering in itself, but this type of physics is difficult to do in ground-based experiments. And so doing this in microgravity is going to allow us to really see what's going on. So you have something cool, how do you make it cooler? You put it in space.
Our ability to study cold atoms is really going to advance our knowledge in areas that will help us in quantum computing, quantum communications, and learn even more about gravity and how it interacts in our universe.
I'm Dr. Ellen Stofan, also known as Dr. E.
And I'm Dr. Thomas Zurbuchen, also known as Dr. Z. I am so excited that we're ready to launch the next Mars mission. But before we talk about this, tell us, where are we here?
We're at the Stephen F. Udvar-Hazy Center, which is one of our 2 National Air and Space Museums. But even more than that, we're behind the scenes, socially distancing, at our Dulles Collection Facility, where we keep aircraft and spacecraft that we don't have room for out on the floor. This is one of the newest objects in our collection. It's the testbed rover that was used for the Spirit and Opportunity rovers out at the Jet Propulsion Laboratory in California. So while those rovers were on Mars, the folks at JPL could use this rover to help understand what was happening up on Mars, where they couldn't get in there and actually fix things.
I'm so excited to stand here next to this. You know, Spirit and Opportunity have really changed how we think about Mars. And you know, you look at it, it's like a golf cart size. Well, the mission we're going to launch, Perseverance, is more like a car, over 2,000 pounds, 7 feet tall, in a much more complex machine with a very different purpose, which is to prepare samples to bring back to Earth. The energy source at Perseverance is the nuclear battery, which is basically hanging from the side.
So that nuclear power source really gives you a lot more flexibility on the rover. You don't have to worry about the sand getting on top of the solar panels and diminishing the power for the rover. So bringing those samples back, that's not going to happen on this mission. That'll happen later. But this is the mission that will actually collect and cache the samples and place them so that that next future mission can come and retrieve them and bring them back to Earth. That's something we've never done before.
Oh, we've never done this before. And you know, we always want to make history in these missions, just like Curiosity has with its landing technologically, but also with its science.
I can't wait. This is going to be so exciting for all of us this summer. We got a few questions in from our audience, so here's one of them. I feel the helicopter is such a cool part of this rover I hear so little about. Can we hear some about what it will be doing and how long is it expected to operate?
The Ingenuity helicopter, as it's called, a high school student in Alabama came up with that name, and I'm really grateful for her input. Ingenuity will be the first controlled flight in another world. So what it's really designed to do is it gets dropped off the surface, it sets itself up, and then it flies a few takeoffs. First, it's just up and down. Just, you know, if you have a remote control thing somebody gives you, same thing. Just go up a foot or two and then down just to make sure you know how to take off and land. And then it starts flying. And then we're going to learn on the surface how we're utilizing it for future use. One of the reasons we actually want to put the helicopter there is because we're thinking if we were there with humans, we'd really like to have scouts that really can go ahead and look at how we can get to a crater, for example, of important science, how we can get down there without having to get stuck on the way, right? Kind of to do the inch-by-inch thing. And we think that scouts like that with data from space can really be an important part, just like we use it on the ground for many applications today.
I'm really excited about it. I'm going to push you on something. Someday there will be humans going to Mars. And I would really appreciate it if they would pick up that helicopter and bring it back here to the National Air and Space Museum, because that helicopter covers everything that we talk about here. So someday.
I think that's exactly the right thing. Here's the next question. How could Perseverance help us potentially for the future human exploration of the red planet?
You know, in a number of ways, from the science it's gathering to an actual experiment on board. First of all, we have an instrument on board called MOXIE that's actually pulling carbon dioxide out of the atmosphere and splitting out oxygen. Oxygen is important because obviously it's something we need as humans to breathe, but it's actually also a component in rocket fuel. And if we're going to have any kind of sustained human presence on Mars, we're going to have to learn to live off the land.
Yeah, there's some things that, just really see the ingenuity of the scientists and the engineers. The calibration target for Sherlock, one of the instruments, actually has specific materials that are of huge importance to human explorations. There's 3 samples of astronaut suit materials there. We learn how these materials interact in the Martian atmosphere. So how cool is that?
That's really cool, because here with our spacesuit collection that we have here at the Air and Space Museum, you can really tell the Apollo astronauts that walked around on the moon, because their suits are covered with a very fine, glassy lunar soil.
Thanks so much for this discussion. What an amazing story we're in the making here. And also for doing this in this environment, full of stories, full of secrets, in a place I've never been before. And I can't wait to come back for another episode of
Easy Science.
Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second 2 missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
When
When you go to another planet, there's just so much potential for making brand new discoveries.
I'm actually putting something together that's flying to Mars.
One way or another, you're going to be on the ground in 7 minutes. We want it to be there safely.
My name is Heather Bottom, and I'm helping prepare the spacecraft that will fly our next Mars rover to the Martian surface.
My name is Diana Trujillo, and I work with robotic arms to collect samples on Mars.
I'm Al Chen, and I lead the landing team for Mars 2020.
My name is Michelle Tommy-Colizzi.
My name is Mujige Stricker.
My name is Eric Aguilar.
My name is Katie Stack-Morgan,
and I'm helping to protect the next Mars rover.
Mars 2020 will be seeking signs of ancient life in the rock record of Mars.
What we're trying to do is to rove around the surface of this unknown planet,
collect samples,
process the tubes as they come back,
to look for things that we call biosignatures,
so that eventually we can bring those samples back to Earth and determine for the very first time, did life exist on Mars?
But also, where could it be preserved for 4 more billion years for us to find it?
Before the rover actually flies, you have to make sure that everything works properly with the flight software and the hardware.
We hit the atmosphere going, 12, 13,000 miles per hour.
After the journey through space, through the vacuum,
we try to test all of our hardware to the environments that we would see.
So that's where a lot of the testing happens behind me.
We spend lots and lots of hours here testing everything.
It gets put in an oven, it gets put in various chambers and clean rooms.
So what we can see over here is the stacked spacecraft.
The robotic arm is actually right behind me.
This is the place where the magic happens.
This is the Mars Yard, and this is where our rovers practice driving over rocky terrain.
There are hundreds of people that have to come together and build a spacecraft.
You kind of have to put those different pieces together and make sure that those pieces all are going to work.
And I feel like such a lucky person to be working on this.
Everything that you're touching and all this hard work that you're putting in the long hours.
20 years, your children will be reading this in their science book.
It feels great.
I used to clean houses, and today I'm trying to find out if there's life in another planet. My name is Diana Trujillo, and I work with robotic arms to collect samples on Mars. What we're trying to do is to rove around the surface of this unknown planet to try to find out if at some point there was life on the surface of Mars. On the robotic arm, we have 2 very interesting instruments. The robotic arm is actually right behind me. We will use the arm to place those instruments or the drill that will collect the sample, which are the ones that will be analyzing the terrain and helping us understand what is it composed of and understanding if there was some traceability of life. And I feel like such a lucky person to be working on this. We're standing on the Mars Yard. The intent here is to demonstrate that we have enough grip to continue to move the rover up and down in any hill on the surface of Mars. I was born and raised in Colombia. There was a lot of violence going on in my country. So for me, looking up at the sky and looking at the stars was my safe place. I came to the US when I was 17. I learned English, paid myself through college, and eventually applied to be working here. We spend lots and lots of hours here testing everything from how it should be moved, from how we're going to configure it. This is us trying to understand how we will use the hardware and the software to get it to do what we want to do on the surface of Mars. It is more about what your enthusiasm, your passion, and if you're determined to do what you want to do in your life, you will find a way.
One way or another, you're going to be on the ground in 7 minutes. We want it to be there safely. I'm Al Chen, and I lead the landing team for Mars 2020. Entry descent landing is all about getting the vehicle from the top of the atmosphere down to the bottom safely. And we hit the atmosphere going, 12, 13,000 miles per hour. We have to deploy a supersonic parachute. And that's all before we get down into powered flight. So we have a new system that'll take over at this point. It'll start taking images of the ground. That'll let us figure out where we are in latitude and longitude. Jezero Crater, the site we're going to with Mars 2020, was actually rejected for curiosity because the site was considered too unsafe. And really the terrain was way too rough. But now we have the ability to land at these places that we never really could go to before. The Jezero Crater site, if you look at it from space, is pretty obviously a delta. We think that Mars was habitable about 4 billion years ago. So the question is not just where was that life, but also where could it be preserved for 4 more billion years for us to find it later. I worked on Curiosity for 10 years, so this is a very familiar feeling. I think I was too young the first time to really realize what was at stake.
Seeing G's on the order of 11 to 12 Earth G's. We are in powered flight.
I've been on the other side of this too. My wife was front and center on Insight. This is actually the same seat that my wife was sitting in for the Insight landing. The same seat that I was in actually back in 2012 for the Curiosity landing as well.
Coming up on entry.
A lot of history for us in this room.
Touchdown confirmed. We're safe on Mars.
We might be uniquely positioned as 2 folks who are married to each other to know what it's like to land things on Mars.
When you go to another planet, there's just so much potential for making brand new discoveries. My name is Katie Stack Morgan, and I study rocks on other planets. So Mars 2020 will be seeking signs of ancient life in the rock record of Mars. The instruments are really well suited to look for things that we call biosignatures, which are signs that ancient life might have been there in the past. To really confirm that life had a hand in creating those signatures or textures, we really do need to bring those samples back. We have capabilities in laboratories here on Earth that we can't fit in a compact instrument on a rover. This is the Mars Yard, and this is where our rovers practice driving over rocky terrain. We work together with the engineers to understand what type of terrain the rover can handle so that we can get to the most exciting places, which are often the most challenging. So our landing site for Mars 2020 is Jezero Crater. What's really exciting about Jezero is that it has a beautifully preserved delta. They tend to be a really good place to preserve evidence of past life. And we look for things like organic matter that get concentrated in the rocks of a delta. So this rock is a sandstone, not unlike a rock that we might actually find in Jezero Crater. We would be interested in sampling a rock like this to understand what each individual sand grain has to tell us about Mars and its evolution. Growing up as a kid, we used to go on lots of hikes and would visit national parks for summer vacations. So when I found out that I had the opportunity to combine geology and love of the outdoors with exploring rocks on another planet, I thought, this is really the perfect type of thing for me to do. Not only could I work on an interesting science project, but I could do it with a big team of people all working together with a focused goal. And I thought, that's what I want to do.